Alright, now that we've worked on area of rectangles, squares, triangles, and circles, we're going to apply it to a little bit more challenging problems. So now we're going to look at compound area, and we'll look at that and see what that looks like in these problems that we're going to work on. So it says, compound area problems. Some shapes don't have a neat little formula. Sometimes you might encounter an odd shape, like a donut or an L shape, or something even weirder and stranger. By the way, don't talk to strangers. Anyway, what you can do is use some of the shapes and formulas you know and either add them together, additive, or subtract one or more from another, subtractive. So let's take a look at an example of each. And we'll start off with the additive. So if you were asked to find the area of this weird shape, this isn't a square, it isn't a rectangle, it isn't a triangle, it isn't a circle, but within this shape I could separate and create two different distinct shapes. So first it says, cut the dimensions into familiar shapes and find missing dimensions. So it looks like if I just draw a line right here, I can split this shape into a rectangle and a triangle. And that's what they do in the second picture here for you. And now, to figure out these side lengths here of the triangle, I'm just using my initial problem here. So let's take a look, because this is pretty challenging. This side here is 5. And this side, up to this point, is 3 units long. So if I wanted to extend it, I know the entire side has to be 5. So what number would I add to 3 to get 5? In this case, you would subtract. You would do 5 minus 3 to get this side as 2. On the bottom half, we know up to here is 4 inches long. And on the bottom here is 7 inches long. So the 4 stops up to here. So that means that the remainder of this, I would just subtract from 7. So 7 minus 4, that's where the 3 comes from. So now I'm going to break it up into the two shapes. I have this rectangle, which is 5 by 4, and I have the triangle, which is 2 by 3. And using the area formulas for each of those, you can find the area of the composite or compound shape. So the area of the rectangle is 4 times 5, which is 20, and then the area of the triangle is 1/2, 2 times 3, which gives you 3. Once you get the two separate areas, you add them together, and that gives you the total area. So when you actually do the problems, you can cut the figures up right on the original, but you probably will have to draw out separate pieces and show the formula for their areas. Let's look at the subtractive. So the subtractive kind of uses the same principles. Let's say I gave you this shape, which has the shaded square and the white square in the center. You know that the side length here is 2, and then on the inside it's 2 and 2. So if I want to find the area of just the shaded region, all I need to do is subtract the area of the smaller region from the larger region. And look at how they separated this out. You have the big square, which is 3 centimeters by 3 centimeters, and you have the smaller square, which is 2 centimeters by 2 centimeters. So to find the area of the shaded region, I just subtract these two areas. So the area of the square is base times height, which is 3 times 3 is 9, and the area of the smaller square is 2 times 2, which is 4, and you would subtract them to get your area of the shaded region. So we're going to work on both of these, and let's try some on the back. Alright, so let's find the area of the shape. So looking at number 1, right away I can tell that I can't use a traditional formula because it's not a normal shape. But for me, I can see a couple ways to do this problem. Right away I see I can break this up into two rectangles. There's this little rectangle here, and I'm going to shade this one in so it's easier to see. And then there's a smaller rectangle, or larger in terms of width, but not as long, over here. So to find the area of this rectangle, this one's pretty easy because I have the numbers. You can kind of cover this part up if you want for right now. And you can see I have the two numbers I need to find the area of the first rectangle. The area of the first rectangle is just base times height. And it's 3 times 7. And that's 21. And it's centimeters squared, because we're dealing with centimeters. The smaller triangle is or rectangle, excuse me, is a little trickier. Because here, covering up the rest of it, I can see that this side is 2, so I have one of the numbers, but I don't know what the top or the bottom are, and that's the other number I need to find the area. So we're going to have to use the bigger picture. And if you take a look, this entire length is 15 centimeters. This smaller length is 7 centimeters. So to find this piece right here, all I have to do is take 15 minus 7. And 15 minus 7 is 8, so this is 8 centimeters. So the other area of the shaded region that I kind of colored over is the same formula, base times height again, because it's a rectangle. And then 8 times 2 is 16, and then centimeters squared. So the area of the entire thing, you have to add those two numbers together. 21 plus 16 gives me 37 centimeters squared. To check our work, we can just shade in and see if our number is on the bottom, and we do get it. The 37 is there, so I know I did that question right. Let's try the next one. So for number 2, same idea. I'm trying to find shapes that I can break these into to help me solve my problems. So it looks like with this one, I can cut this up into this shape down here and then another rectangle there. I'm going to shade in the two different shapes so I can see the differences. Alright, for this rectangle, the smaller one, I know this side is 4, but I need to figure out the other side. And the only information I can see is the 9 feet and the 6 feet. Those are the ones that are running parallel on the sides. So if this whole thing is 9 feet, and up to here is 6 feet, to figure out the remaining part, I would just take 9 minus 6. And 9 minus 6 is 3. So this side right here is 3 feet. So the area of the first rectangle is base times height again. 3 times 4 gives me 12 feet squared. The second rectangle, the white one, that's not shaded, I know this side length, I know this is 6, that's given to me, that's perfect, but I need to figure out this part. This one's a little bit trickier. Look at the opposite side, and let's see the side lengths. We have 4, and then it's telling us that this part up to here is 3, so this is 3 feet. So in total, this part is 7, because 3 plus 4 is 7. So the area here is base times height again, and it's going to be 6 times 7, which is 42 feet squared. So adding those two together, 12 plus 42, you get 54 feet squared. Taking a look on the bottom, see if you can find that answer, and it's there. Let's try number 3. You're going to skip number 4, so you can cross out number 4, and you can cross out number 5. Those are more of a challenge problem if you want to challenge yourself. But we're going to do number 3, and then you're going to try number 6 without me. And you can come check with me when you finish, and I'll give you your work for today. So for number 3, hopefully by now you're seeing at least you're able to split this up into 2 shapes. That's the most important part of these problems. And for me, I'm seeing there's a triangle right here that I can split these 2 shapes up into. So I've got the triangle, and then I've got this rectangle. The rectangle is easier because in the rectangle I can cover up the information I don't need, and you can find the area of that shape. The area is just base times height. So we have area equals base times height. 17 times 10, it's 170 inches squared. That's the area of the rectangle. For the triangle, remember we need the straight sides, the up and down side and the horizontal side. So the 7 doesn't really help us at all in this case because we don't know we need these 2 pieces. And actually we might be using the 7 with Pythagorean theorem, so we'll take a look and see. Alright, so looking at the sides that are opposite each other, this is telling me that this up to here is 13 inches and up to here is 17 inches. So these are opposite of each other, so they should be the same. So the remaining pieces that I need, this part's got to be 4 because 17 minus 13 is 4. So now I need to figure out what this side length is. Remember for triangles you can use the Pythagorean theorem. So you got a squared plus b squared equals c squared. This one's a little trickier. We have 4 squared plus b squared equals 7 squared. 4 squared is 16. 7 squared is 49. Subtracting 16 on both sides. So we got to do the square root of 33. Alright, so we got the square root of 33, so using your calculator, second x squared 33, 5.7. So B equals 5.7. So to find the area of that triangle, its area equals 1/2 base times height. So area equals 1/2 base times the height. So you get 11.4 inches squared. So adding the two areas together, you get 170 plus 11.4 is 181.4 inches squared. I'm taking a look. On the bottom, it's going to be this guy, just with the rounding. We rounded to the nearest tenth, and they rounded to the nearest hundredth, so we're pretty close in terms of the numbers that we matched up there. Alright, so skip 4 and 5, and let's see if you can do number 6, and I'll try to get you started. Hopefully you can see the triangle that's up here. The rectangle is going to be easy to do because you know the two sides. It's going to be 10 and 10 there. What's harder is going to be this triangle up here. So I'll kind of get you started. Let's worry about this piece of the triangle that's right there. If I know this entire side length is 10, and this side length is 6 up to here, how much more would it have to get me to get to 10? So I use the sides that are opposite of each other. 10 minus 6 is 4. So this is 4 inches. Doing the same thing on the other side. This side length is 16 and this side length is 10. So if I want to figure out from here to here, how long is that side? You just do 16 minus 10 because 10 is the opposite side. So this part right here is 6 inches. So now you have the two side lengths you need to find the area of the triangle, and then you have the area of the rectangle to add. Try that one and come check with me, and then you can work on your practice problems.